Bueno, pues vamos a seguir ahora con una sesión que yo creo que va a ser del máximo interés. Va a continuar con la idea fundamental de esta demo session sobre la necesidad de avanzar hacia materiales que tengan propiedades únicas. Tenemos la suerte de contar con dos de las personas que son líderes en este campo a nivel mundial. Entre ellos tenemos a Skylar, que viene de MIT, del laboratorio de Self-Assembly. Skylar, cuando quieras. Y también tenemos a Joanna, que viene de la Universidad de Concordia en Canadá y es la directora del laboratorio de textiles electrónicos. Muchas gracias. So you want to have a seat? De forma muy breve, ¿cómo va a funcionar este panel? Cada uno de ellos va a hacer una breve presentación sobre su tecnología, sobre cómo las fibras electrónicas, los textiles inteligentes, nos abren nuevas oportunidades, de hecho, a un sector que en la Comunidad Valenciana es muy importante. Y luego vamos a hablar de algo todavía más futurístico. Si la impresión 3D es ya algo nuevo, bueno, vamos a escuchar ya la impresión 4D, a ver qué es lo que nos va a contar Skylar de MIT sobre esto. Una vez terminen sus presentaciones, van a volver al panel, se van a sentar y yo les voy a hacer una o dos preguntas como máximo a colación de lo que nos han contado. Y finalmente abriremos el turno de preguntas. Para estas preguntas, como algunos de ustedes no tienen Twitter o no están interactuando vía Twitter, lo vamos a hacer con un micrófono. Entonces, aquellas personas que quieran preguntar, pues les rogaría que salieran aquí a la parte central donde están las escaleras y habrá un micrófono y podrán hacer la pregunta que les parezca más oportuno. Bueno, pues sin perder más tiempo, I would like to introduce again to Joanna. She's coming from Canada, from Concordia University, and she's going to be telling us about smart textiles. Okay, thank you very much, Joanna.
Thank you. So thank you all for coming. It's a pleasure to be in Valencia, and I'm really enjoying the symposium so far. So as Javier said, I'm going to be talking specifically about electronic textiles, and I will take a second to define it, since actually a couple of people have asked me what the heck I'm talking about. So electronic textiles and reactive garments specifically, which is what I'm specializing in, involve the integration of electronic components, so either for sensing or for actuation, into flexible textile-based substrates. So I'm particularly interested in this field from the point of view of social and cultural identity communications. I have this quote here from John Carl Flugel, who's actually a Freudian psychologist. This is a quote from 1930. And this is really my point of entry into this field. Issues such as individual, occupational, sexual differentiation, social status, communication, etc. And all of these kinds of ideas, issues, and needs that we have as individuals in society can be greatly enabled and developed through the use of electronic textiles and the development of these reactive, interactive garments. So on one hand, I actually have a research lab at my university where we focus a lot more on artistic and performative designs, I suppose, but that are very much based on the integration of highly functional fibers. So the example that you just saw here, this was actually a set of garments that include a shape memory alloy called nitinol. So all of these garments moved on the body and opened and closed and basically were these animated sculptures on the bodies of the models, of the dancers. The real important aspect of my research is to work with existing manufacturing technologies. So I'm a really big believer that true innovation can come when we mix old technologies with new technologies, or when we don't turn our back on the old technologies. And this is especially significant when we think about manufacturing and scalability. So I definitely work with existing technologies such as weaving, knitting, etc. But the innovative component comes from the integration of functional fibers. So fibers that can change shape, conductive fibers, fibers that can change color, etc. And because I believe that that is really the fundamental path to innovation in this field, I'm really also involved in developing the next generation of functional fibers, and specifically fibers that can generate electricity, store energy on the body, and change their state in a variety of different ways. So this is my research. This is maybe 15, 20 years in the future. If we're lucky, we'll be seeing these fibers on the market being used in large textile mills. But I also have a second life with my startup company, Signal, where we are developing a product that can be manufactured currently using current materials, of course, cutting-edge materials, and using current manufacturing possibilities. So our first product is a shirt that, with integrated biosensing capability, we are sensing in our current product 2 different biosignals, breathing on one hand, as well as a heart signal. So not heart rate, not just the number of heartbeats per minute, but a full ECG, which then allows us to determine various emotional and physiological states by looking at what's called heart rate variability, so actually the amount of noise or regularity in that signal. And I'm just going to show you a very quick promotional video from the company, to give you an idea.
What if life became a little smarter simply by putting on a shirt? What if being connected meant really being in touch? What if what we wore helped us get through life a bit more smoothly? Or be healthier, fitter? Imagine if our clothes helped us take better care of our loved ones. Or on demand provided that crucial medical information. Or maybe brought us together in magical moments we simply could not have before. Well, Signal is making it possible.
So we're looking not only at tracking, assessing, and detecting different patterns and differences and trends in our biosignals, but also obviously at predicting our future health and well-being. So we are really focused on well-being in general, but also, of course, are looking at many other applications that might involve sports. Just general wellness, permeates all of these daily activities that we're involved with, so sports, general activities, and this is all related, of course, to medical and health information as well. So this is a great product, but unfortunately, it's not easy to manufacture because there are incredible challenges in the manufacturing of electronic textiles. Some of the underlying challenges, the fundamental underlying challenges are really tied to the fact that there are these very well-established industries, both around textile and garment production, as well as around consumer electronics. And these industries are entrenched, established, they usually operate on very low profit margins. So we really need to consider almost a complete reinvention of manufacturing strategies to bring these two capabilities and sets of expertise together to make these products. Electronic textiles also fundamentally bring together soft, flexible things with elements that don't have the same kinds of resistance to being stretched and deformed. And currently, a lot of electronic textile products require a lot of hand assembly, a lot of finishing. So therefore, there are considerable scalability, reliability issues. Our solution to this is to leverage as much as possible these existing manufacturing capabilities that we have. In Canada specifically, I'm in Montreal. Montreal has a long history of textile and garment manufacturing, which obviously, as elsewhere in North America and Europe, has been in decline over the last couple of decades. But we're looking at actually reinvigorating those existing manufacturing capabilities through these value-added, more functional products. So using existing capabilities and adding a little bit on top of it in order to create these products. So currently, as you saw, we have two different things we're making. The undergarment, so it's an undershirt, as well as these leisure wear, tight kinds of, this is a yoga shirt, right? And we have three different approaches to manufacturing. I'm repeating the slide here. So the first one, which is in production right now, is what we call our textile-driven solution, where we use circular knitting. Here you see on the bottom a photograph. This is a Santoni, an Italian-made circular knitting machine. We're working with a factory in Montreal. But instead of only using the nylon, the polyester, or cotton blend fibers that are traditionally used, we're also introducing these functional fibers, so different kinds of conductive and resistive fibers into the knit process. So what's really exciting about this is we can actually, in a couple of minutes, it goes very, very fast, you almost can't see it, knit a full garment that has the sensors embedded in it already. Of course, there is a little bit of finishing to be done at the end to finish the edges, connect some of the additional electronic components. But this method allows us both to leverage the capabilities we have in Montreal and have this very scalable method to produce many garments in a short amount of time with these integrated electronic components directly in them. We're looking at also miniaturizing and looking at different methods around MEMS for printing, some of the sensing technology. Currently, the shirt comes out of the knitting machine, and we have to attach a box to it, which then communicates to your phone via Bluetooth. We're looking at ways of embedding those elements in the future in the shirt as well. But what's most exciting to me is the third version, the third horizon of our product that I am currently developing more in a research context, which will try to move a lot more of the functionality into the fibers. So we can actually have this approach of quickly manufacturing, using existing machinery, quickly manufacturing a shirt with not only the sensors, but also some of the processing and power transmission, as well as communication technology embedded in the fibers themselves. So this might not be possible simply using knitting or weaving, and we're very excited about the future potential of these more complex manufacturing pipelines that might involve layering textiles with different materials through either laminating, heat fusing, or even 3D or 4D printing technologies to create these multi-layered complex materials that still can be called textiles, that are still flexible, stretchable, deformable. And I'll show you a couple of examples of the fibers we've been developing, moving towards this vision. I deeply believe that developing functional fibers is the future of electronic textiles because of all of the manufacturing issues that exist around the integration of traditional electronic components and soft substrates. And I'll just show you a quick example, of how much sense it makes to move in that direction. So this is me actually sitting at a Jacquard Loom, prototyping one of the textiles that changes color or changes shape or something. So this is a loom that has 2,000 warp ends. Each one is individually addressable. A Jacquard Loom can weave a very complex visual pattern, but can also then weave a complex functional pattern. And you can see here, can I lower the sound a little bit, please? You can see here how that process scales in an industrial context. So this is an industrial Jacquard loom. And you see once it starts weaving, just how quickly that textile magically appears out of thin air. And it's a complex structure, it's a complex pattern. It uses different fibers to make this pattern. So we've been using these industrial manufacturing approaches to do things like integrate. This is a conductive yarn that's woven directly into a textile. This is a yardage with these integrated conductive components that basically form antennas for sensing proximity. These are my students, but this was actually developed for a dance company, for a dance performance, where the dancers interact with the textiles and change the sound and the illumination on the stage. So these are not dancers, they're engineers. Although this could be some kind of performative dance, I suppose. We also use the same manufacturing process to make, this is a panel, this is a prototype I made for Herman Miller a long, long time ago, 15 years ago almost. That is a panel that changes color. So you see these elements change from yellow to brown and back to yellow using a thermochromic ink that is overprinted on the textile that changes color based on resistive heating in these conductive fibers that are woven directly into the textile. The idea there was that worker productivity would increase if the cubicle dividers actually changed color during the day to give them a little bit of this ambient visual distraction. But so this is all done on existing manufacturing equipment. So our project, this is me with one of my collaborators, Maxime Skorobogati. Our project is really trying to move in this direction where we can make traditional garments using to a great extent existing manufacturing capabilities that we have with some additional highly technical, perhaps finishing stages, to create garments that can do all kinds of magical things, harness energy, store energy, display those energy changes on the body in visual states. So right now we've been able to develop a photonic bandgap fiber that can transmit light and change the color of the light, of the transmitted light, by emitting and conducting different parts of the frequencies. And actually have those woven on one of these mechanical looms. We're also developing capacitive fibers using the approach of co-rolling different polymers and different materials and then heat drawing them to create fibers that can also be woven. We do a lot of design explorations around the future of these fibers, of course, at the same time. And we have also developed highly successful, this is not a fiber yet, but this is an energy storage material that can be cut into thin strips and then woven into textiles. So we're making small steps, basically, in the direction of what we consider the future potential of electronic textiles, which is, again, leveraging as much as possible the manufacturing capabilities we have back in Canada in order to reinvigorate, that industry, layering them with some additional emerging manufacturing technologies, and really looking at future materials that can be integrated into that process. So thank you very much.
Thank you, Joanna. So let me just ask you one question before Skylar gives his talk. One of the things that are very inspiring from your presentation is the use of these garments to get personal information that can be used for diagnostics or many other things. The obvious question will be about privacy. That's something everybody talks about. But actually, what I'm curious about is, with all this amount of information, how you communicate that in a way that is just not, again, another app on your cell phone and more data, and how we go from huge amount of information to knowledge to make good decisions that, in this case, may affect your well-being. So how do you feel about that?
So, definitely the data analytics part of our company is the biggest division in our startup. I think, I tend to approach that question really from the behavior point of view, right? Mm-hmm. How can we actually target our behaviors? So not from the interface design point of view, even though, this is the gesture we all make. But really from the behavioral point of view. And then once we define behaviors that we want to identify, that we want to target and change, then move from that to looking at what kinds of algorithms can be deployed to create that kind of knowledge that you're talking about, and then how to develop an interface, whether it's an active or a passive interface, in order to help effect the change that we want to.
Okay. Wonderful. So I'm going to ask just one question to both of you, and then I'm going to open the floor for questions. We have still 15 minutes, so I think it will be plenty of time for this discussion. So both of you are professors. You are teaching. You are in teaching institutions. My question is very simple. Do you think we are educating the next generation of engineers, architects, designers in a way that they can think so they can contribute to this kind of technologies? Because again, it's very important, the materials, electronics, photonics, hybrid materials, but at the end of the day, it's a lot about disruptive innovation. Are we teaching in a way that we can create these multidisciplinary groups that can create this kind of amazing technology, which are just mind-blowing?
Well, we are.
Great.
And actually, it's funny you should ask that question, because Marcelo Coelho, who worked on the project, was in fact my undergraduate student in Montreal, and then went and worked in Boston on the 4D printing. So we actually, 10 years ago, when I became a professor, we developed a new program of study, which is called Computation Arts. And basically, we accept about 60 students per year. And it's basically a program where they do half of their studies within design, within the arts, and half of their studies within engineering and computer science. And this is at the undergraduate level. So we're bringing in students who are 18, 19 years old in some cases. And we really actually try to foster exactly this kind of innovative, multidisciplinary approach to problem solving and to creativity through this program. I think it's a very successful program. One interesting thing just to share with you is that we thought it would grow. We thought we could start accepting more and more students every year, but we seem to actually have found this kind of natural cutoff point for students who are ready to take on that kind of challenge, to really be thinking about problems from a multitude of different perspectives. So it does take a specific kind of individual, but I think those kinds of programs are essential actually to develop the kind of innovation you mentioned.
Yeah, I think one of the key attributes is this cross-disciplinary collaborations. And if you look at all the credits from our projects, or even the students that are in the lab, it's mechanical engineers, biologists, architects, you name it, students who have dual degrees in architecture and energy studies, and you name it, it's across the board. And I think that's super key for us, that we're not only just throwing out wild ideas and not only looking at like what's next, which is sort of the traditional design mantra in a way, but rather really interested in like fundamental science and fundamental research on the science and engineering side, and figuring out like very technically how this works. And so it's this collaboration between different disciplines where there's a common thread between it, but that they can offer insights for these collaborative projects. And so I think by teaching towards that side, that students can collaborate with different interests and backgrounds, that we are ready for these type of technologies and processes. And we may not have exactly the right tools, but the next generation of students can help us develop those, because they're interested in streamlining it. And
wonderful.
It's more about the mindset.
So you said that you attended this biology conference to show this DNA printing project. How was the reaction from the professionals, from the biologists, on this kind of contribution to the conference?
Yeah, I guess you're talking about Biomod,
yes,
where we presented it. So Biomod it's an undergrad design competition. So all of my undergrad students presented it. I think we were the anomaly in the room. They call it a DNA design competition, but they really mean like a biologist competition.
Yes.
And so, you know, we were the only designers in the room, and so we threw this out there, and I think it was a bit like, whoa, what are they talking about? But it wasn't negative at all. They were more asking about like, oh, what could we do with this? And you know, the competition was one thing, and we had great feedback from the audience, although I don't think they saw it. It was kind of in left field. They're like, whoa. But the collaboration with the biologists that we worked with was amazing, because we would throw out an idea and they would just be like, yeah, we can definitely do that. I never thought about that. Yeah, we can definitely do it. And so they start getting excited and kind of push us along, and then we come up with new ideas. And so that's kind of how it went.
Wonderful. So ahora vamos a tomar preguntas de la audiencia. Si alguno de ustedes quieren hacer alguna pregunta, en castellano o en inglés, se pueden acercar al micrófono, lo tenemos ahí en la escalera y estaremos encantados de responderles. ¿Una persona? Después tenemos lunch, o sea que si no va nadie os voy a dejar sin postre. Espero que alguna persona tenga alguna curiosidad sobre lo que estamos viendo ahora. Si no, desde luego a mí no me faltan preguntas. ¿Una pregunta? Parece que se acerca una persona al micrófono. ¿No? Bueno, pues entonces todo es muy... Parece que quiere el postre del lunch. Bueno, so Joanna, let me ask you about this question on batteries. One of the things you are doing is on electric textiles, and this technology requires batteries. Again, that's more for my field, the energy field. How limiting is the fact that you need to use batteries? And do you see, I mean, you commented a little bit on this topic before, but how do you see this advanced textile as a way to collect, harvest, and store energy?
So that's definitely why I'm interested in moving in that direction. You know, there are many obstacles to overcome, of course, along the way. It's, you know, we're just made the first steps. Because when we talk about batteries, it's not just a question of having this bulky element that needs to somehow snap into the system. It's also a question of then having a process for recharging those batteries. So this is traditional batteries, right? It's also actually a huge environmental question. You know, batteries are inherently very harmful to the environment. So, you know, although I'm extremely excited about this battery leather that we've made, you know, it's going to have probably a very negative impact on the environment in terms of what happens in the life cycle of the garments, right? So there are a few challenges that we are very concerned with in terms of power and powering these electronic textiles, but very much with this background of also looking at environmental impacts. And that's where these ideas designed for disassembly or even self-disassembly, I think, are crucial to deal with these questions.
I think there's also another take on it, which we've gone, and mostly because I don't have a background in the EE side, electrical engineering side, more the CS side, but is that I see materials as a new opportunity to challenge electronics in a way, that it may not be our traditional notion of electronics, like throwing in resistors and capacitors and microcontrollers and batteries in that sense, but maybe we can have the same functionality with much more elegant solutions, with fibers and multi-materials, et cetera, and they can store energy, they can respond in certain points, they could have simple logic, and so maybe we can think about electronics in a little bit different way.
Yeah, there's research in that area anyway. Yeah. There's a question right there, wonderful. So if you don't mind to approach to the microphone.
I can try,
okay? Okay, go ahead. I think that will be fine.
I would like to know, how do you link your researches, your investigations and your model with the market? Yeah. What are the ways you put it in the market and how long it takes to you?
So, as you saw from my presentation, my research in my research lab, in my academic research lab, is much more speculative, much more forward-looking, right? So these are ideas that we're trying to develop. And research in an academic context, really comes from having these ideas, these questions, and we saw a few slides and various presentations about this. Then there's a very long time frame where you need to actually work with a partner for manufacturing, huge investments, etc., right? So, however, I still find that so that's going to happen. Maybe my students will make it happen. Whoever comes after me, will have these battery fibers. However, at the same time, the work that I'm doing with my startup company is greatly influenced by my research work. So maybe not the exact materials that we're developing. They're not going into our product yet. But some of the questions we're asking and some of the solutions that we're finding in research then give us ideas for manufacturing of our other products. So there's this elegant relationship in that sense. But there's definitely, it's two different research processes for sure.
Yeah, on my side, so on the research lab perspective, our mandate is to invent new technologies and push knowledge forward and make discoveries and look for the future. So it's not necessarily driven by market, and I think there's actually a good separation there, because if we only looked at profitability or market demands, then we would not develop many technologies because they lose money for a significant period of time, and therefore, research would not move the world forward. So I think it's important to separate profitability from research initially, but we also have the interest, and currently we collaborate with many industry-leading companies, and also many labs spin out technologies, and so there is that other side that you are also market-driven in some ways, or at least you look for opportunities with the technologies you develop for potential markets. But our main focus is more on the research side.
Wonderful. ¿Más preguntas? I do have a question if nobody else. Probably this will be the last one. So, Joanna, when you started, you said that in the Montreal region, the textile industry is declining. We know that that's happening in other parts of the world. It's not limited to the textile industry, it's also in the manufacturing. Kind of the hope for the advanced economies is that through advanced manufacturing, we can reclaim part of that manufacturing back to North America and Europe. But from your perspective, do you think that the emerging economies are lagging behind on advanced manufacturing, or that we will be surprised by China, India, Brazil, Russia, on how they're actually advancing also in this smart manufacturing, and we are not be able to reclaim so much of that market as we may think.
So I've been working in this field for over 15 years, getting close to 20 years now, and I've had different adventures trying to commercialialize electronic textile products. I had a startup company in Boston in the late 90s, and I've approached this manufacturability issue repeatedly over the last 15 years. And I do have to say that that promise of this being a niche market, these value-added products, reinvigorating our industries, that lag that you mentioned is getting shorter and shorter, right?
Yep.
So in a sense, it's almost like maybe we can develop the pipeline, the manufacturing pipelines, using our existing expertise and experience, and then layering on top of that. But there definitely isn't that much of a lag now for industries in the countries you mentioned to catch up very quickly.
Yeah, I think there's obviously this hype and this hope that at least additive manufacturing, everyone is pointing to that. That's the solution, and that's how we're going to bring manufacturing back to North America. And specific, Obama is saying it, and there's these manufacturing initiatives. So we, as researchers and colleagues, we believe in this. Anyone working in this space believes in it, but we're also a bit skeptical in a way. Neil Gershenfeld, who's a collaborator of mine at MIT, has this quote about the microwave to cooking. We thought the microwave was going to change cooking, and we would never cook the same. And we all have microwaves. They're super valuable, but there are other ways to cook as well. And so we sort of see 3D printing as that as well. It's another tool that can do super powerful things, but it's not going to replace existing manufacturing technologies. And we need to address some of those major hurdles if we really want to take this on as a new opportunity. But the other key aspect is that it's democratized, that there is this vision that many, many people can customize and make things. And if that's true, then it's not going to give the US or North America a competitive advantage necessarily. It may, but it may be more and more ubiquitous.
So, si alguna persona tiene un interés que no pueda aguantarse sobre hacer alguna pregunta, si no, creo que los pósters los están poniendo ya en las mesas. Pues, si les parece bien, por favor, agradezcamos a Joanna y a Skylar por esta discusión.